In this video we will learn more about data structures. This chapter describes some things you have learned about already in more detail and adds some new things as well. So we already know that lists have additional function which they roles, but but we hadn't heard about using lists as Slack. So let's learn how it works. The list method make it very easy to use a list as Slack, where the last element added is the first element retrieved. Last in, first out. To add an item to the top of the Slack, we can use append function, append method, yes. To retrieve an item from the top of the stack, use pop without an explicit index, for example. Using list as a quiz, it is also possible to use list as a queue. There is first element added, the first element retrieved, first in, first out. However, lists are not efficiently for this purpose, while appends and pops from the end of this list are fast. Doing inserts or pops from the beginning of a list is slow, because all of other elements have been shifted by one. To implement a queue, use collections dequeue, which was designed to have fast appends and pops from both ends. For example, list compressions. List compressions provide a concise way to create lists. Common application are to make new lists where each element is the result of some operation applied to each member of another sequence, or iterate, or to create a subsequence of those elements that satisfy a certain condition. For example, assume we want to create a list of squares, like something like note that the creates or overrides a variable named x that still exists after the loop completes. We can calculate the list of squares without any side effect using a lambda expression, or equivalently, which is more concise and readable. List compression consists of brackets containing an expression followed by a for clause, then 0 or more for or if clauses. The return will be a new list resuming from evaluating the expression in the context of the for and if clauses which follow it. For example, this list combines the elements of two lists if they are not equal, and it's equal to something like that. Note how the order of the for and if statement is the same in both these snippets. If the expression is a tuple, in previous example, it must be preceded. What about also list compressions can contain complex expression and nested function. What about nested list compression? The initial expression in a list compression can be any arbitrary expression, including another list compression. Consider the following example of 3 by 4 matrix implemented as a list of list of length 4. The following list compression will transpose rows and columns As we saw in previous section, the nested list comp is evaluated in the text of the flow that follows it. So this example is equivalent to z, which in num, which is turn, is the same as in the real world. You should prefer built-in function to complex flow statements. The zip function would do a great job for use case. The del statement. The del statement, there is a way to remove and item from a list given its indexing instead of this value, the del statement. This differs from the pop method, which returns a value. The del statement can also be used to remove slices from a list or clear the entire list, which we did earlier by segments or of an empty list to the slice. For example, del can also be used to delete entire variables. For example, del a. Referencing the name a hereafter is an error, and the list until another value is assigned to it. We will find the other uses for del later. So let's try to use our del statement. Let's go to our compiler, delete it, create variable which will be equal to 2. Let's print our variable and let's delete our variable how we can see here. Let's copy it and paste here del x and print it. So name x is not definite, because it is deleted. So it's so del statement is work. Also, we can talk about tuples and sequences, but I will learn you how tuples and sequences work later. I want to tell something more about del statement, because del can also be used not only to delete these statements, but in other methods. So I think it's all for del statements, for nested lists, for a list in general, and using list and quiz. So thank you for watching this video. See you in the next one. Bye.